an argument for a consciousness hypothesis. Young children and pets have trouble understanding adult speech and compensate for the handicap with a sensitive antenna for emotions. Emotions can identify a person's authority, bias, and dependability. Weakness invites abuse, and strength evokes respect. Still, critical thinking claims to rely on logic. Although we would never admit emotions are the highest decision makers, logic is often delegated to explain even the most bizarre, incongruent behavior after it happened. How can we learn about emotions and consciousness? The mind emerged in the physical universe, and energy transfer and use are fundamental to all biology. Thus, in the understanding of consciousness, we must start with physics. The brain interacts with the environment through the sensory system. Stimulus activates the neural system and triggers activation, and the response recovers the so-called resting state. The resting state is a slow brain waveform without a stimulus. Therefore, sensory perception can be considered a harmonic motion. Harmonic motion is ubiquitous. Pendulums, springs, and swings are typical examples. Sensory perception starts and ends in resting states. A1 and A2 have the same parameters, such as entropy and frequency. Although the neural system maintains the resting membrane potential, the synaptic maps of A1 and A2 differ in complexity due to the stimulus energy input. In thermodynamics, systems are characterized by their temperature and entropy. Entropy is the arrangement representing the lowest work potential of a system, and temperature is the particle's average kinetic energy. In the brain, greater activation doesn't increase action potential, but increases the neuron's firing rate. Therefore, the frequencies are analogous to emotional temperature. So what is a thermodynamic cycle? A thermodynamic cycle transfers heat and work on varying pressure, volume, and temperature until the cycle eventually returns to its initial state. The cycle is reversible and exchanges only energy and information, not matter, with the environment. The same is true for cognition. However, the blood glucose maintains the resting membrane potential and forms the action potential, ensuring the neural system's fluid signal transmission through the synapse. Therefore, the brain's energy supply functions as the oiling of the mechanical engine. In contrast, energy input produces work in engines, whereas information input by stimulus engenders intellect in the form of synaptic complexity in the brain. The forward direction of the cycle is called the exothermic cycle, which releases energy. And the reverse cycle is called the endothermic cycle, which requires heat energy for its operation. Therefore, the endothermic cycle depends on the exothermic cycle. Going back to emotions, science learned that emotions are a continuous and constant presence in the brain. Their involuntary nature and action-producing power indicates their energy nature. Indeed, we can separate positive and negative emotions based on their energy profiles. Positive emotions, such as reward processing, require an initial energy investment by releasing neurotensin in the thalamus, for example, a structure in the brain, but they remain energy frugal. Negative emotions do not require energy investment, but accumulating a stressful trace in the prefrontal cortex makes them wasteful. Therefore, positive emotions are endothermic and negative emotions are exothermic processes. Let's look at this in more detail. Positive emotions' initial investment can come from internal or external sources. For example, focus is necessary for patience, persistence, and even meditation, which is an energy investment. And external inputs are financial, moral, or emotional support, love, and even beauty that elevates the mind. Endothermic energy accumulation can be represented by the steps of a staircase, leading up to persistence, confidence, and wisdom. Energy accumulation forms future orientation. From this perspective, information scarce positive emotions allow a slowing down, inspiring a broader vision and degrees of freedom. The thermodynamics of perception shows that it takes a long time to develop intellect. In contrast, negative emotions come for free. We don't need cognitive investment to get angry, depressed, fearful, anxious, or critical. However, detail-oriented negative emotions induce a narrow vision, block cohesive understanding, and enclose the mind in the past via regret, remorse, and repetitive thinking. However, the cognitive burden leads to periodic energy loss, represented by the sand pile model that produces regular avalanches. So we can never predict the time of an angry outburst or even physical violence. Conant and SB said, every good regulator of a system must be a model of that system. The brain regulates the environment, therefore it adopts its physical laws and organization. The two fundamental theories of physics are quantum physics and relativity. Quantum cognition, a decades-long field, can explain problems in psychology, sociology, and economics. The cognitive space is analogous to the field representation of gravity. As shown earlier, the perception cycle centers on the resting state. The probabilistic, chaotic, and reversible cycle gives rise to a unified, stable, discrete belief that allows reflection, prediction, and temporal orientation. The contrasting field and quantum qualities represent an orthogonality analogous to the wave-particle duality in quantum mechanics. How does the brain acquire a physical projection of the environment? The pinhole camera was used by artists in the Middle Ages to produce an upside-down, inverted, reduced image of a lit object on its back wall. The brain's sensory projection is analogous to the pinhole camera. In all vertebrates, the incoming and outgoing nerves cross to the contrasting side of the body and the brain by the so-called decausation. Decausation produces an upside-down, inverted, and tiny sensory projection on the cortical surface. The animal learns to interpret the image in infancy. Although decausation requires a mind-blowingly complex axonal organization, it follows the same physical laws like the pinhole camera. Therefore, sensory processing is an automatic response to the environment information dumping onto the sensory system. Consciousness is a constant, unending sensory processing, and it takes considerable cognitive effort to block or slow down sensory noise. For example, the eyelid didn't evolve to reduce visual input, but to protect and lubricate the eye in animals that move to dry land. Indeed, mammals that live in water, such as dolphins and whales, use the eyelid to a minimal extent, such as for sleeping. In conclusion, perception is a thermodynamic process giving rise to memory, learning, and intellect. The brain can produce intelligent responses to stimuli by adopting particle organization. The fermionic mind hypothesis shows that consciousness is the awareness of being separate from the environment. The second law of thermodynamics expresses the environment's increasing entropy. Intellect's ability to efficiently absorb entropy from the environment makes it a thermodynamically preferred path. The increasing entropy supports technological evolution because a technologically advanced civilization is a more efficient energy user and odor generator.